This lecture is 10.3, going over polygons, perimeter, and tessellations. To begin with, we're going to take a look at what are polygons. So polygons are shapes that can be drawn, made up of connected line segments. And you'll notice that it has an interior and an exterior side of the polygon. And the sides are usually equal length. Such is called a regular polygon. So we have our three-sided figure called a triangle. Four-sided is a quadrilateral. Five-side, pentagon. Six sides, hexagon. Seven sides, heptagon. And 8 sides, octagon. We do have polygons that have many more sides than just 8, and we will be acquainted with one shortly. Next are the quadrilaterals. We have a parallelogram. Parallelogram is made up of two sets of parallel lines. The opposite sides have equal measure, and you can tell they have equal measure in that they have these little markings. For instance, on this parallelogram, I have one little tick mark on the top and on the bottom. That's saying that those two sides are equal length. And is such the case for the opposite sides with the two tick marks. And they have interior angles that have the same measurement. This one has one tick mark here and this one here. So the angles on the diagonal have equal measurement. Next we have the rhombus. The rhombus is that all sides are equal as indicated with one tick mark on each of the sides. Remember, we're still discussing quadrilaterals, four-sided figures. A rectangle here is also a parallelogram. Opposite sides are going to be parallel. Notice that each little corner creates a little square, which is a 90 degree. All right, so we'll get that in there. Opposite sides are parallel. A square, all sides are equal for the square. And each angle, again, has a 90 degree measure, such as the rectangle. Lastly, we have the trapezoid, which is a quadrilateral that has exactly one pair of parallel lines. And that would be this top part and this base part here. Let's take a look at our first problem. The first one asks for the perimeter. It says, if the fencing costs $5.25 per foot, find the cost to enclose the field with fencing. So we have this field that we're going to put fencing around. We want to know how much do we have to pay at the end of the day. So what we should do first is recognize that we have a rectangle. And we learned that rectangles have equal lengths on opposite sides. So that's telling me that since the bottom part is 42 yards, then this top part must also be 42 yards. The opposite side of the 28 yards is making this side 28 yards. And this is a rectangle. Next thing we want to take a look at is that it's telling us a hint here with this title, perimeter. The perimeter is the sum of all sides. What that means is we have to add all the sides together. And that will tell us how much fencing we need. So the perimeter for this rectangle is going to be adding all sides. So you can say 42 plus 42 plus 28 plus 28. And if you add all these sides together, you should get 140 yards. All right, so we need 140 yards worth of fencing. The other way that you can also do this is perimeter has a formula for a rectangle. The perimeter of a rectangle, and I'm just going to call this P for perimeter, is 2 times the length plus 2 times the width. And if you take a closer look, here we have on this first part, 42 plus 42 is the 2 times the length. And we have the 28 plus the 28. That is 2 times the width. All right, so you can add all sides up or you can use this formula. The next thing we need to take a look at is that the perimeter is 140 yards. It says on here in the statement, the fencing costs $5.25 per foot, but our measurement is in yards, so we need to convert that. So we're going to take the 140 yards of fencing and we're going to multiply this by 3 feet. This will give us a total of 420 feet of fencing. All right, so what you need to recall on this part is that 1 yard is equal to 3 feet. And that is why we multiplied by 3 feet. The next part we want to take a look at is to find out how much it will cost us. Now that we know we have 420 feet of fencing, and it is going to cost $5.25 per foot, we're going to multiply this and we're going to come out with $2,205. And that would be our fencing cost. So let's take a look at this problem one more time. The perimeter is the sum of all sides. We recognize that we had a rectangle, so we need to find how much fencing. So we found the perimeter by adding all the sides together and coming out with 140 yards. We need 140 yards of fencing, so from here we took this amount and we converted it into feet. 140 yards times 3 feet gives us a total of 420 feet. So we need 420 feet of fencing. After that, we want to find the fencing cost. So we took the 420 feet and we multiplied it by the cost of $5.25. And it will cost us $2,205. On our next problem, it is once again asking us to find the perimeter of the figure shown. If we take a close look at the figure, we can see that some of the sides do not have a length to them. So we need to find the length of those sides first, then we can find the perimeter. So what I'll do is take a look at all of our horizontal lines. And this top one here, I'm going to put that green in there, is 4 feet in length. Then this other horizontal line is 8 feet in length. So that shorter line plus the longer line should give me this full length on this base, the side here. So I have 4 plus 8, which will give me a total of 12 feet for the length of this side. Next, I'm going to take a look at the vertical lines. And this vertical line here is 4 feet. And this vertical line here is 5 feet. So if I add 4 plus 5, I should get the total length of that far left-hand side. So 4 feet plus 5 feet will give me a total of 9 feet. And now that we have the length of all our sides, to find the perimeter, we can add all our sides together. Perimeter is equal to, and I'll start with the very top side is 4, and make a little walk around, plus 4, plus 8, plus 5, plus 12 plus 9. So I started in the upper left-hand corner and went clockwise and just counted all of my sides together. When I add these two, or all these sides together, I should get 42. So the sum of all the sides is the perimeter, and adding all sides together, we get 42 feet. A rectangle field is 5 times as long as it is wide. If the perimeter of the field is 540 yards, what are the field's dimensions? So when it asks us what are the field's dimensions, they're asking you to find the length and the width. All right, so let's go ahead and draw a rectangle. And since it's asking us or telling us 5 times as long as its width, we don't know what the width is. So we're going to go call that width X. It is X yards long. Then it says that the field is 5 times as long as it is wide. So that means the length of it is 5 times the width, or 5x. Once again, we know we have a rectangle where opposite sides are of equal length. And it says that the perimeter on here is given as a total of 540 feet. So here's what we know so far. We know the perimeter, which is the sum of all sides, is 540 feet. And if we add all these sides together and reminding ourselves that the opposite sides have equal length, we will end up with x plus x plus 5x plus 5x. Please remember that these x's have an understood coefficient of 1 in front of them. So that is 1x plus 1x plus 5x plus 5x. So now I have 540 is equal to 12x. What we'll do is go ahead and continue to solve this equation. To undo this multiplication, 12 times x, we're going to divide by 12. What you do to one side of your equation, you do to the opposite side. 12 divided by 12 will leave you 1, and 1 times x is x. Over on this opposite side, you'll use your calculator, or you can do long division. 540 divided by 12 will leave you 45 yards. Now, if we recall, I said the width is x, the length over here is 5x. So what we found so far is just the width. We need to go find the length. The expression that represents length is 5x. 5 times x. And since we now know that x is 45, we're going to take the 5 times the 45, which gives us 225 yards. And that is equal to our length. So when it says find the dimensions, we can write the length is 225 yards. And the width is 45 yards. Switching pace just a little bit, we're now going to go on to the angles of a polygon. We discussed what a polygon was on the very first slide. And now it says that we can find the sum of the measures of all the angles of a polygon with n sides is equal to, and this is the formula we're using, n minus 2 times 180 degrees. N represents the number of sides that we have of the polygon, and this whole entire expression represents the sum of all the measures of the angles. So if I were to look at this figure that's below, you're going to go ahead and see my little green marks in here. These are the angles of this polygon. And if I added all of these measures, degree measures of the angles, I am going to find that it is equal to this n minus 2 times 180 degrees. So let's go ahead and work this problem, starting with step A. A says to find the sum of the measures of the angles of the octagon. So the octagon has 8 sides, and if you're not sure, you can go and count all of these sides. So knowing that the sides have 8, we're going to go and find the sum of all the angles. So I'm going to substitute in 8 for n minus 2 times 180. And when we calculate this, we find out that the sum of the angles is 1080 degrees. Part B is saying, for this figure that's shown, find the measure of angle A. So I'll make this a little bit bolder. This is angle A right here that we're looking for this measure. So the measure of angle A is going to be found by taking the sum of all the angles, 1080 degrees, divided by the number of sides of this polygon, which is 8. And we're coming out with each angle will be 135 degrees. Therefore, the measure of angle A is equal to 135 degrees. Next, we're going to go grab part C. And part C is saying, find the measure of the exterior angle, angle B. So they're wanting us to find this measure here of angle B. So we learned in a previous section that when two angles create a straight line, that they're called supplementary angles. So angle A plus angle B creates the straight line right here. So therefore, they're called supplementary angles. And supplementary angles add up to be 180 degrees. So the measure of angle B is equal to 180 degrees minus the measure of angle A, 135 degrees. And this will give us measure of angle B to be 45 degrees. So the first step we had to do was find the sum of all the interior angles of this polygon using the formula n minus 2 times 180 degrees. Next, it asked us for the angle measure of, the measure of angle A, and that gave us 135 degrees by taking 1080 divided by 8. Lastly, it asked for the measure of angle B, We know that angle A plus angle B together will equal to 180 degrees because they're supplementary angles. Therefore, the measure of angle B is equal to 45 degrees. We will next move on to tessellations or tiling. So you may have seen patterns like this or mosaic type patterns on backsplashes and floors. Some people decorate the tops of their tables with tiling. And one of the nice things about these patterns is that they're well fitted. So in order for this to be considered a tessellation, it says each tessellation is possible because the angle sum of every vertex is 360 degrees. So let's take a look at this bottom photo, and I'll highlight that vertex with a blue that I'm looking at. So they're saying if you take a look at a vertex, any vertex on here, even if I wanted to look at this vertex right here, it's saying if I take the angle, each angle that connects to that vertex, it should have a sum of 360 degrees. So in this case here, this first angle here is 135 degrees. And the angle for this shape right here is also 135 degrees. And the measure of this angle here is giving it to us. It is a 90-degree angle. And if we add all of these together, we will get 360 degrees. Because it is equal to 360 degrees, it is considered a tessellation. Our next slide is questioning as to, is this a tessellation? And if it cannot be a tessellation, we need to be able to explain why. So we have a regular pentagon, five-sided figure. We have three of them, and we have them placed in such a manner so that we have the interior angles measuring 108 degrees for each one. So if we take 108 degrees, we have three of those, and we add those angles together, we get 324 degrees. Now, 324 degrees does not equal 360 degrees to be a tessellation. So therefore, it cannot be a tessellation because it does contain a 36-degree gap here. So you have to think if you were lying these as tiling on your floor, you wouldn't want to have a big gap like that in your pattern because you'd see all the grout or the underneath grout, and it wouldn't look very appealing, in my opinion. So if there's a gap and the interior angles do not equal that 360 degrees, it is not a tessellation. All right, so pay particular attention to this problem. You will see it again, something similar to this on my math lab. And it has a few parts to it. Part A says, name the type of regular polygons that surround each vertex. B, determine the number of angles that come together at each vertex, as well as the measure of those angles. C, use the angle measure from part B to explain why the tessellation is possible. So the first thing I'm going to do is go and grab one of my vertices, and I'll just grab this one right here. It's a little red one that I'm putting. And I'm going to say this is angle number 1, angle number 2, and angle number 3. All right, so let's take a look at that dark blue area. And I'm going to name that. That dark blue is a square. All right. We know a square has all equal sides. And we also know the interior angles of a square is 90 degrees. So I will say the measure of that angle 1 is equal to 90 degrees. Next, I'm going to look at my shape, my second shape, and it has 1, 2, 3, 4, 5, 6 sides to it. So this is a hexagon. Let me remind myself up here. N is equal to 4. This is the number of sides. Hexagon, this has 6 sides. All right, so we need to find the angle measure for the hexagon. How many degrees is one angle worth? So we're going to use that formula of n minus 2, in this case 6 minus 2, times 180, the sum of the angles. This is going to give you a total of 720 degrees. Next, we want to find how much one angle measures. So 720 degrees divided by the 6 sides. And I'm coming up with 120 degrees. 120 degrees for each angle, interior angle. So therefore, my measure of angle 2 is going to be 120 degrees. And if you take a look below here, you can almost determine by process of elimination of which answer would be the name of the type of polygons, part A. So we have squares, and the squares are listed for all 3 options, A, B, and C. And then we have hexagon for a 6-sided figure. And that would leave me with option A to choose from. In my process of elimination, now I know that that third shape, this third interior shape, is a dodecagon. So a dodecagon has 12 sides. And we'll do the same process of finding the measure of one interior angle. We will take 12, subtract the 2, and multiply it by 180 degrees. So the sum of all the interior angles of this dodecagon is 1,800 degrees. To find the measure of one angle, we'll take 1,800 degrees and divide it by the number of sides, which is 12. This leaves me 150 degrees. So the measure of angle 3 is 150 degrees. So for part A, our shapes will be a square, a hexagon, and a dodecagon, and therefore we chose the answer A. Part B says determine the number of angles that come together. So we can see that we have 3 shapes that come together, which have 3 angles that come together. So the answer for part B is 3 angles that come together at each vertex. And then the measure for each one of those, we found that one on the square is 90 degrees. The one for the hexagon is 120 degrees. And the dodecagon, that measurement is 150 degrees. And that would conclude part B. And then part C is to use the angle measures from those answers in part B to explain why the tessellation is possible. So in this case, we know that if we take 150 degrees plus the 120 degrees plus the 90, we're looking for the sum of 360 degrees. And this gives us 360 degrees. And this is why it is possible to create this tessellation because of the measurement. Continuing from the previous page, it says the number of angles is 3. And this was that part B. And we came up with 90, 120, and 150 degrees. This tessellation is possible. And this concludes the lecture.